Hello there, we're going to talk about 6-5 today, solving linear inequalities. Now you notice here the difference is it's inequalities instead of equations, and we dealt with inequalities back in chapter 3, and that's where instead of an equal sign we have an inequality symbol such as greater than, less than, greater than or equal to, or less than or equal to. And the solution of a linear inequality is any ordered pair that makes the inequality true. And if you'll remember from chapter 3, inequalities are a little different than equations because they will always have more than one solution, or they may have no solutions, but they will never just have one ordered pair that will work. And these are actually really fun to graph. You get to do some shading and things like that, which is kind of fun. So we'll start out much like we did when we had linear equations, and that is verifying whether an ordered pair is a solution or not. So here I have the ordered pair 4, 5, and it wants to know if that's a solution of y is less than x plus 1. So if I plug those in to x and y, I would get 5 is less than 4 plus 1, which would be 5 is less than 5. Now the question I ask is 5 less than 5? And the fact is it's not. It's equal to 5, but it's not less than 5. So this would not be a solution to the inequality. Now if it was, let's say it had less than or equal to right here, then it would be a yes, because 5 is equal to 5. But it's not just less than, so this would be a no. Let's look at another one here. Here I have the ordered pair 1, 1, and we want to know if that works and y is greater than x minus 7. So if I plug those in, I'd get 1 is greater than 1 minus 7, which would give me 1 is greater than negative 6. Is 1 greater than negative 6? Yes, it is. So this would be a solution of that inequality. And that's all you have to do for those type of problems. Just plug it in for x and y, and then say yes or no based on whether your statement at the end is true or false. Now let's get to the fun stuff, to graphing them. The first step of graphing them, and make sure you have these steps written down in your notes, is to solve the inequality for y. That means put it in slope-intercept form. And this is something we've been working on for a while, so I'm hoping that you're getting pretty good at this. So we solve it for y, and then we graph the line, just like we've been graphing with the slope and the y-intercept in regular equations. And so then we graph that line. Now we use a solid line for less than or equal to, or greater than or equal to, and we use a dash line for less than or greater than. And then finally, if the inequality is a greater than or equal to inequality, we're going to shade above the line to show that the solutions of the inequality are everything above the line. And if it's a less than or equal to symbol, we shade below the line to show that the solutions are everywhere below the line. So here's our first example. Now this one's nice because it's already in slope-intercept form here. It's got y solved for, so I don't have to do that first step. So then my next step is to just graph this line. Well, if you'll remember back from chapter 5, okay, we got y equals mx plus b. So m is the slope here, which is negative 2/3. And b is the y-intercept, which is 1. And when we learned back in chapter 5 how to graph these, we'd start at 1 on the y-axis, because that's my y-intercept, and then it's down 2 over 3. And again, I like to make a lot of dots just so I have nice straight lines. Okay, now then I have to decide whether I should make a solid line or a dashed line. And to decide that, I look here at this symbol. I have a greater than or equal to symbol. And since it's a greater than or equal to symbol, that means that I'm going to use a solid line when I graph. So let me go grab a solid line out of here and graph that. Okay, so there's my line. And then the last thing I got to do is look at the symbol in the problem. And if it's a greater than symbol or a greater than or equal to symbol, I shade above the line. And this one is, so I'm going to shade above my line. And so I'm just going to put shading all up here. Now what that means is that any number that's either on this line, any ordered pair I should say, that's on this line or in the shaded region is a solution of this inequality. So all of those, I mean there's infinite number of ordered pairs there, they're solutions to our inequality. Now as you probably know, they won't always come solved for y, because that would just make our lives too easy, as you know. So if it's not already solved for y, I have to solve it for y. So here I'd want to subtract 4x, subtract 4x. It's going to give me negative 3y greater than negative 4x plus 12. I'm going to divide by negative 3. And then I have to remember here, if I divide by a negative number in an inequality, I have to flip the sign. Hopefully you remember that. So then I have y is less than 4/3 x minus 4. So now I have it solved for y. I can see that my slope is going to be 4/3 and my y-intercept is going to be negative 4. So I'm going to start at negative 4. And then from there I'm going to go up 4 over 3. Up 4 over 3. Now here I have a less than symbol, so that means that I need to use a dashed line when I graph this. Okay, so there's my line. And then since it's a less than symbol, that means I shade below the line. Okay. And with the dashed line, what that means is that any point on the line is not a solution to the inequality. It's only everything below the line. As I said before, the solid line means that the line is also part of the solution. Dashed line means it's not. It's kind of the same idea as the open and closed circle thing when we graphed inequalities back in chapter 3. Okay, so that's the first part of 6.5, and we'll finish the rest of it up in the part 2 video, and we'll see you guys tomorrow.